All right. Today we're going to talk a little bit more about parabolas. I know it's everyone's favorite topic, and we're going to talk a little bit about finding the vertex in a different manner that some people may find easier. First of all, let's talk about the a value, right? So my a value is that leading coefficient, or the coefficient of x squared. In this case, on the pink equations. On the pink equation here, it is positive 1 and the parabola faces up. On the blue equation, it's negative 1 and it faces down. Okay, and when it's facing up, there is a minimum value to the parabola, and when it's facing down, like the blue equation, there is a maximum value to the equation. And that's important when you're using modeling, because sometimes you want to minimize a cost, for example, or you might want to maximize your profit or an area. And those always occur at our beloved vertex that we've talked so much about recently. Here are 4 equations, right? And when you're asked whether it has a minimum or a maximum value, you're just going to go right to this leading coefficient here, or the coefficient of x squared, which in number 1 is positive, so that equation is going to face up. Here in number 2, it's negative, and so it's going to face down, positive and negative. And so here we go again. So it's positive 2, so it has a minimum value. And when it's negative 2, it has a maximum value. When it's positive 1, as in number 3, it has a minimum value. And when it's negative 0.5, it has a maximum. And we aren't too concerned about the rest of it, but when we're asking that question. Next. But the key for a lot of these problems we're going to do for the homework is finding the vertex. And we know how to do that. By completing the square, we've done a bunch of that so far. First, you're going to isolate the variable. Then you're going to divide by a to make a equal 1. Then you're going to add half of b squared to both sides, where I've added 1 to both sides there. Then I'm going to rewrite as a perfect square, that right side. Then I'm going to subtract 1 to solve for g of x and get it by itself. Multiply by 3. And finally, I'm going to subtract that last 1. So then we can find out that our vertex is 1, negative 4. And that gives us a lot of information. So my a value there, the 3, tells me that you have a minimum value. The equation faces up. The minimum value occurs when x equals 1, and that minimum value is negative 4. Personally, this is my favorite method because it kind of does it all at once, and I'm quick at it. But there's another method. The x-coordinate of the vertex will always be negative b over 2a. For example, if I had this equation, f of x equals negative 2x squared plus 20x minus 47, my b is this 20, and my a is negative 2, and so I just plug that in. Negative 20 over 2 times negative 2, or the opposite of 20 over negative 4, which will be 5. So the x-coordinate of the vertex is 5. Then I can just take that 5 and plug it into the equation. So here's the original equation, negative 2x squared plus 20x minus 47. And then I'm going to find f of 5. I'm going to plug in 5 everywhere there's an x and evaluate my way down, and I will find that it is 3. And so I can find that by plugging in, so I can find that vertex 5, negative 3. Now let's look at this in a question that you'll have on your homework tonight. So given this equation here, negative 2x squared plus 20x minus 47, it has a maximum value because a is less than negative 2. And my vertex is 5, 3. So where does the minimum or maximum value occur? When x equals 5, and you just report the x-coordinate of the vertex. What is the function's minimum or maximum value? The max is 3. Yeah, the maximum value is 3, and you're just going to report the y value. Which way is better is your choice, but when the numbers are ugly, go with x equals negative b over 2a. Here's a word problem that's similar to ones you're going to have in the homework. An aircraft factory manufactures airplane engines. The unit cost is in dollars to make each airplane engine depends on the number of engines made. If X engines are made, then the unit cost is given by the function C of X equals 1.1x squared minus 418x plus 53,580. What is the minimum unit cost? Do not round your answer. What the heck? Oh, so anytime they mention a minimum or maximum, they just want you to find the vertex. And they want you to find the vertex of this equation that is given. So I'm going to go and I'm going to take this equation, 1.1x squared minus 418 plus 53,580, and I'm going to plug in my b value, which is negative 418, and over 2 times 1.1. I'll put a negative sign in there, and it'll come out being 190. Then I take that x value and I plug it in, and solve to be 13,870. Now, so the x value, if you remember by looking at the question, the x value are engines made, and the unit cost is the y value. So in other words, at 190 engines, the unit cost will be its minimum value and will be 13,870 for each engine. And so to answer the question, you need to be careful about what question they're asking. Okay. The minimum value is the y. When they're asking you for the minimum cost, that is the y value. Okay. And that would be, you just report the y coordinate of the vertex, 13,870. They could also ask you for what number of engines, for example, will give you that minimum cost. And in which case you want the x value, or 190 engines. So you just need to read the question really carefully about whether they want the minimum cost or the number of things that gives you that minimum cost. Anyway, I hope this is helpful, and you should proceed to homework 5 and work on that.